Question number 12 from May 2015, higher level paper 1, time zone 2. The cubic equation x cube plus px square plus qx plus c equal to 0 has roots alpha, beta and gamma. By expanding x minus alpha times x minus beta times x minus gamma, show that. And in part A, we need to derive three relationships between the coefficients p, q and c and the three roots. So in part A, if we multiply the first two brackets, this will be x times x squared times x minus beta x, then minus alpha times x, so minus alpha x, and minus alpha times minus beta, so plus alpha beta. This bracket then will be multiplied by x minus gamma. So now if we expand this, x squared times x is x cubed, and then x squared minus gamma is minus gamma x squared. Then minus beta x times x is minus beta x squared, and minus beta x times minus gamma is plus beta gamma x. Then minus alpha x times x is minus alpha x squared, minus alpha x times minus gamma is positive gamma alpha x, and then alpha beta times x is positive alpha beta x, and alpha beta times negative gamma is negative alpha beta gamma. So from here I have written the like terms together, and in the next step I have factorized negative x squared from this expression, so we're left with this, and from this expression I have factorized x and I have left this as it is. Now if we compare the coefficients, we know that the coefficient of x squared is p, and in this expansion the coefficient of x squared is this term, so we can write that p is equal to negative inside the bracket alpha plus beta plus gamma. And similarly, the coefficient of x is q, and in this expansion the coefficient of x is this expression, so we can write q is equal to alpha beta plus beta gamma plus gamma alpha. And finally the constant term is c, and in this expansion the constant term is negative alpha beta gamma, so we can equate the two expressions. Now it is now given that p is equal to negative 6 and q is equal to 18 for parts b and c below. Now in B first part, in the case that the three roots alpha, beta and gamma form an arithmetic sequence, show that one of the roots is 2. So for B first part, what I did is I let beta be the second term of the arithmetic sequence. So alpha will be equal to beta minus d, and in this d will denote the common difference. So alpha is beta minus the common difference, and gamma is beta plus the common difference, because I've assumed beta to be the second term of the arithmetic sequence. So now from here we can use this relationship where we know p is equal to negative 6. So negative alpha, which is beta minus d, plus beta, which is just beta, plus gamma, which is beta plus d. This is equal to negative 6. So from here we can cancel the negative signs, and the negative d and the positive d will cancel, and we left with 3 beta is equal to 6. Solving for beta, we find that beta is equal to 2. Now for the second part, hence determine the value of c. So for the second part, what we can do is we can use this relationship now where we know q is equal to 18 and beta is equal to 2. So we can write alpha beta, which is 2 minus d times 2, plus beta times gamma, which is 2 times 2 plus d, plus gamma times alpha, which is 2 plus d times 2 minus d. This is equal to 18 as told in the question. So if we expand this bracket, this will be 4 minus 2d, and this will be 4 plus 2d, and this is just a difference of squares, so this will be 4 minus d squared, and this is equal to 18. So now the negative 2d and positive 2d will cancel out, and we're left with 4 plus 4 plus 4, which is 12, minus d square is equal to 18. Now if we solve for d squared will be equal to negative 6, and then we can take the square root and find that d is equal to the square root of 6i, and we know that the common difference is a complex number. Now finally we can use this relationship for c. We can find that c is equal to negative, now alpha is 2 minus root 6i, which is 2 minus d, and beta is just 2, and gamma is 2 plus root 6i. Now from here, if we apply the difference of squares formula to this bracket and this bracket, this will be 2 times 4 minus 6i squared. Now to make this absolutely clear, what I've done is Now this will be 2 times, now 4 minus 6 I squared is equal to negative 1. So this will be negative 1, close bracket, and this will be negative 2 times 4. Now negative 6 times negative 1 will be positive 6. So 4 plus 6, and this will be negative 2 times 10. This is what I have here. So this gives us c is equal to negative 20. Now for the final part, C. In another case, the three roots alpha, beta and gamma form a geometric sequence. Determine the value of C. So for C part, what I have done is I let beta be the second term of the geometric sequence. So if beta is the second term, then alpha will be beta divided by the common ratio, and gamma will be beta multiplied by the common ratio. So now what I've done is we can use this relationship where we know p is equal to negative 6. So negative alpha, which is beta upon the common ratio, plus beta, which is just beta, plus gamma, which is beta times the common ratio. This is equal to negative 6. So now the negative signs will cancel, and I have made the denominator common. So this will be beta plus beta r plus beta r squared upon r equal to 6. Now from here I have multiplied r with this 6 to get 6r, and I have also factorized beta. So we left with beta inside the bracket 1 plus r squared is equal to 6r. Now from here I have solved for this bracket. So 1 plus r squared is equal to 6r upon beta, and this is the first equation that we have derived, and this will be used later. Now secondly, we can use this relationship for q. So we can write alpha times beta, beta upon r times beta, plus beta times gamma, which is beta times beta r, plus gamma alpha, which is beta r into beta upon r equal to 18. Now from here this will be beta squared upon r, this will be beta squared r, and the r's will cancel, so we left with beta square, and this is equal to 18. Now from here I have made the denominator common to get this, and then I have multiplied r with the 18 to get 18r, and I have also factorized beta square from the numerator. So this factorizing beta square inside the bracket gives us 1 plus r squared, and this is equal to 18r. Now again, if I solve for this bracket, 1 plus r squared, this will be equal to 18r upon beta squared. Now this is the second equation that we've derived. Now notice that 1 plus r squared is equal to 6r upon beta, and also 18r upon beta squared. So what I can do is I can equate these two expressions. From here r's will cancel out and one of the beta will cancel. So if we solve for beta is equal to 18 upon 6, and beta will be equal to 3. Now finally we can use this relationship for C. So C will be equal to negative alpha, which is 3 upon the common ratio, times beta, which is just 3, times gamma, which is 3 times the common ratio. Now the r's will cancel out, and C will be equal to negative 3 cubed. So we find that C is equal to negative 27. And this is the answer to question number 12.